Here we have a pre-calculus problem. Okay, let's go to the question. Find the domain, vertical asymptote and x-intercept of the logarithmic function. Enter your domain using interval notation. Here we have a logarithmic function. Okay, now let's find the domain of this logarithmic function. For any function, a domain is nothing but the values of x for which y is defined. So the same thing we have to do it in this function also. That is, we have to find the values of x for which this y is defined. For that, I need to consider the argument of the logarithm. What is the argument of the logarithm? Usually a logarithm will contain two parts. One is base and other one is argument. Here the base is the value we have over here, that is 10, and this is called argument, this x negative 3. And logarithm is always defined only for the positive value of its argument. That is, if I want this logarithm has to be defined, so the value of this argument x negative 3 has to be positive. That is, x negative 3 has to be greater than 0. Okay, now let's solve for x in this one. For that, we have to add 3 to both sides. When I add 3 to both sides, and 83 positive 3 will cancel out. Then I'm getting x greater than 3. That is, when x takes a value greater than 3, so this one will be positive. Then the value of this logarithm is defined, and also the value of this y is defined. So in the given logarithmic function, this y is defined when x is greater than 3. Okay, now let me mark this inequality on the number line. Let me take the number 3 on the number line. Since we have greater than sign over here, we have taken empty circle. If it is greater than or equal to, we can take filled circle, but greater than, we can take just empty circle at 3. Since x is greater than 3, we have to consider the values on the right side of 3. So this is a solution. This is a graph of this inequality x greater than 3. So now we can write this one in interval notation, that is 3 comma positive infinity. So when x takes a value in this interval, so y is defined over here. So the domain of the given logarithmic function is 3 comma positive infinity in interval notation. Okay, let me write the stuff over here. So domain is 3 comma positive infinity. So usually along with infinity, whether it's positive infinity or negative infinity, so we'll be taking parenthesis because this value is not included. And here along with this 3 also I'm taking parenthesis because 3 is not included. Because we know that x is greater than 3. That means 3 is not included. Any value greater than 3 is included. So therefore the domain of the given logarithmic function in interval notation is 3 comma positive infinity. Okay, now let's find the second part of the question, that is we have to find vertical asymptote. Whenever I want to find vertical asymptote of a logarithmic function, so I have to do a very simple work. That is, I have to take the argument of the logarithm and it has to be equated to 0 and solve for x. Okay, let me equate the argument to 0. Now let's solve for x in this equation. For that we have to add 3 to both sides. When I add 3 to both sides, 83 positive 3 will cancel out. I am getting x equals to 3. So this is the equation of the vertical asymptote. Let me write the stuff over here. So the equation of the vertical asymptote is x equals to 3. Okay, now let's do the third part of the question, that is we have to find the x-intercept. Okay, not only for this logarithmic function, for any function, if I want to find the x-intercept, so I have to plug in 0 for y. So the same thing I have to do for this logarithmic function to get the x-intercept. That is, I have to plug in y equals to 0 over here. When I plug in y equals to 0, then I'm getting 0 equals to log base 10 of x negative 3. Okay, now I have to solve for x in this equation. Actually, this is a logarithmic equation. I mean, this equation is in logarithmic form. Now to solve for x, what I have to do is I have to come to this equation to exponential form. How can I come to this equation to exponential form? For that, we have to move this logarithm along with this base 10 to the other side of the equation. When I move this logarithm along with the base 10 to the other side, we have to ignore this logarithm. We have to consider only the base 10 on the other side of the equation. The value which already exists on the other side will become the exponent of this base. Now on the right side, we can take this x negative 3. Any value raised to the 0th power equals to 1. So the value of this one is just 1 because of the exponent 0. Then we get 1 equals to x negative 3. Okay, to solve for x, we have to get rid of this negative 3. For that, let me add 3 to both sides. When I add 3 to both sides, it is negative 3. Positive 3 will cancel out. 1 positive 3 is 4. 4 equals to x. Okay, now I got the value of x, that is x equals to 4. Okay, now let me write the x-intercept over here. Just a moment. X-intercept already we know that y coordinate is 0. That is, we plugged in y equals to 0 and we got the value of x, that is 4 comma 0. So this is the x-intercept of the given logarithmic function.